Hi, my name is Trubac, and in today's presentation I will talk about my experience with Houdini and show you how I used it to create environments for my real-time short film, Deserted. But before we dive into that, here are just a few words about me and my work. I'm currently a freelance digital artist focusing primarily on procedural art. After graduating with a degree in computer science, I decided to focus on VFX. So for the last 2 years, I've been particularly interested in using real-time technologies in VFX, as I believe there is a lot of potential, especially when combined with procedural generation. What I like about procedural art is that it's relatively abstract in terms of problem solving, like that you look at the thing you want to create and try to find rules that describe it, rather than manually push and pull polygons, for example. There are also usually many ways to solve a problem, and I like the creative process behind it. Speaking of which, about 2 years ago, a good friend of mine challenged me to create a city using nothing else than Substance Designer, and to my surprise, I managed to win the Substance Insanity Award with it. So besides creating regular Substance materials, I really like to step outside the zone from time to time and experiment a bit. So here I have just a couple of examples. This is the city generator. By the way, there are not any separate 3D objects. It's 100% Substance Designer. The whole thing is just a single highly tessellated plane with a height map. So obviously it's not something you'd use in production, but I took it as a challenge or experiment to see how far I can push things. Similarly, here is the forest hill generator, where you can control the shape of the hills, size of the lake, as well as season, for example. Then I also got the opportunity to work with Level Up Digital, so I created a tutorial for them where I explain my entire process from start to finish. Again, this is just a tessellated plane, but here I also experimented with triplanar mapping to see if I can get some texture details on the sides of the walls and rocks. And last but not least is this sand dunes generator. Here is a still image, but it allows you to simulate the wind flow, so you can also create seamless animations with it, where the sand is being blown away and accumulated again, forming new dunes. Okay, and now we come to the main topic of this presentation, which is about the film Deserted. So first, I'd like to show you a short trailer, and then we'll continue with the breakdown. Alright, so everything you just saw was rendered in real time using Unreal Engine 5 on a mid-range laptop. The main idea was to do as much as possible procedurally, so all of the environments in the film, including deserts, cities, as well as ships, buildings, and materials, were created using Houdini and Substance Designer. This film is my graduation film at Tomáš Bati University in Zlín, and I was the only person involved in this, so I had to come up with the concept and did pretty much all the 3D modeling, texturing, animation, compositing, as well as sound design. So the film was made in about 9 months, and I was learning Houdini kind of on the fly. Okay, so here are the key areas I'm going to talk about today. We'll start with Houdini HeightFields, where I will show you how I use them to generate desert plateaus and sand dunes. Then I will break down the city generator, and finally we'll have a quick look at a relatively simple way of generating spaceships. Alright, so let's start with the desert plateaus. The goal was to create a rock formation while maintaining a good control over the shape and final appearance. I designed it with a modular approach in mind, so the generator creates smaller rocks that can be later combined in the engine to form larger formations, similar to those found in Tassili National Park in Africa. Okay, so in the reference images on the left, you can see that it has a very specific look with that flattened top and quite heavily eroded slopes. So I tried to mimic that in Houdini, and on the right, you can see the final result in Unreal Engine. Cool, so here you can see the individual steps showing how the final rock is made. So we start with a custom hand-drawn shape. It can be anything, really, but what's cool about this is that you can kind of art direct the look of the rock so that it fits the shot you're working on, for example. And then it's just a process of adding noise and erosion passes. So I will now switch to Houdini and show you how exactly I did that. Alright, so here we are inside Houdini, and let's take a look at this graph. So first, here is our height field, which is fairly low res. And then we draw our main shape here. Then we blur this, and we start to introduce some noise to this. Then we blur it and add it back on top so that we kind of get this smoother profile here. Then we add secondary noise to this to further break up the shape a bit. We can even also add these tiny rocks around the main rock to make it more visually interesting. Then we can blur it and remap to change the profile of the mountain. Then we distort again. And right now the ground is pretty much even everywhere. So what we can do is to introduce some noise to this as well and add this back on top. And here is our main erosion pass. So what I did here is that I cranked up the hydro as well as precipitation so that we kind of can get these stronger cuts in the terrain, which kind of defines the main look of the rock. If you are interested, you can pause the video and take a look at the parameters if you're interested in this kind of effect. Then we remap again to change the profile and make it more rounded. Then upsample and distort to get more details in there, and then we run another erosion pass to kind of create these smaller cracks. Then we do our terracing. So first we mask out the slopes, then we multiply them with this noise to kind of break up the mask, and then we do the terracing, which we also distort to kind of make it look more natural. Then we kind of work on the outside area a bit again. So we first mask out the border, smooth it, invert this, and we add this noise to this, just to the outside area, and add this back on top. And also we add one more erosion node to kind of connect everything together. Here we can add these cracks to make it more visually interesting, but right now they are pretty much evenly strong all around, which doesn't look very realistic, especially around the rock. So what we can do is to kind of mask out the outside area, smooth it, and so we can get something like this. Then we upsample again and run another terracing. Again, we mask the slopes, then we add noise to this, and terrace, which we also distort. We can also even run thermal erosion on this to kind of break it up even more. And then we run another erosion pass to get even these smaller details in there. And as we saw in the reference, the top was pretty much flat, so we also clipped the top of the mountain here. But first we kind of add this noise, so we kind of push it up a bit so that the top is not perfectly flat. And now we raise it up again with noise so that it's not super flat. And now we do more terracing. And because the top is not like perfectly flat, we kind of get these details in there, these kind of cracks, thanks to this terracing here. And then we again distort and move on. So we resample or upsample actually. And then we have our final erosion here that kind of connects everything together. And I wanted to add even more details on the slopes, so I calculated this flow field here. Again, I multiplied this with noise mask, so that it's not as regular. And then I also multiplied this by mask, which is only masking the slopes. And then we kind of got these additional details on the slopes. And finally, we run this final distort so that we can kind of get these crunchy details in there. And then we also add this additional noise to this. Then we do slumping so that we kind of connect everything even more together. And finally, we do one more slumping on the sides around the main rock. And this is basically the whole thing here. Alright, and then I converted the height field to mesh, extracted various maps that were created by erosion nodes, and finally poly reduced it to a more reasonable poly count. Then I took this low poly mesh along with all the various maps and brought that inside Substance Painter, where I textured the model. In the end, I believe I generated around 5 of these rocks, and later in the Unreal Engine I placed them around the scene and combine them to form bigger formations. Okay, and that wraps up the desert plateaus, and now let's take a look at sand dunes. So, since the whole film takes place in the desert, I had to find a way to create vast deserts that reach all the way to the horizon. I originally wanted to code a solver for this, however, when I experimented with HeightFields, I found that I could achieve relatively good results by simply combining different HeightField pattern nodes, then distorting them with HeightField distort node, and finally running a bit of erosion on them, where I adjusted the settings to mimic wind erosion. And by utilizing this kind of artistic approach, I was able to exactly shape the look of the desert without any need for heavy simulations. I also wanted the desert to be diverse and interesting to look at, so I tried to avoid having only one pattern tiling over the entire landscape. While studying the reference images, I was blown away by all the shapes and patterns that the dunes form. You can see some examples in the pictures on the left, for example. So I wanted to capture this diversity in my generator as well. In the image above right, you can see a screenshot from Houdini, and in the bottom right, the final form of the dunes in Unreal. Okay, and now let's take a look under the hood. So the core of the system is 6 separate generators with different dune patterns that have been combined to create the final desert landscape. Each generator has a different dune size, and by combining them in the optimal way, it is possible to create a smooth transition from large to small dunes, as you can see in the image. And now let's open up Houdini and we'll have a look at how this works. Alright, so here we are back in Houdini. Here you can see we have our 6 generators here. So let's take a look at the first one. As you can see, it's just a simple pattern node with ramp. And then we distort it, distort again, and then we merge it with another pattern, which is rotated at different angles so that we kind of get these different directions in there. Then again distort, and then we add this kind of another noise pattern or noise texture to this, and distort once again so that we kind of get this result here. And now let's take a look, for example, at some bigger dunes. So here we start with this whirly noise. Then again distort, another distort, so that we kind of get these smaller like details in there. Another distort. Now it's kind of more wavy. Then we add this pattern there. So now we kind of have even more of these waves pronounced, and another distort node. So as you can see, it's just basically a lot of distort nodes pretty much everywhere in here. And now let's quickly take a look at the mask. So you can see it's pretty messy, but it doesn't really matter because we distort it again and then blur it. And the idea behind this is that we always kind of dilate the original shape, distort, and again blur it. And here we kind of work our way through this, always kind of expanding the mask. And here we just use this layer node with replace type to kind of combine them together. So here we have our first, second, and we kind of slowly, gradually add these there so that we have the transition. And then we also add this noise texture to this so that it's like not perfectly flat. We have some elevation differences there. And then we also push the middle up a bit. Then we do this final distort so that we kind of create this flow in there and help kind of connect everything back together. And this is our terrain here. And then I've added a couple of more details. However, the most important part of this is here. So here I've cropped a smaller section of the terrain so that I can demonstrate different erosion settings I've used to simulate various surface imperfections. So this chunk is now 400 by 400 with grid spacing 0.5, which is quite important because erosion works differently or behaves differently at different resolutions. And so this is our first example here. As you can see, it creates this kind of interesting waves there. And this is the setting for the erosion node if you're interested in this particular effect. Then we have this second effect, which is slightly different. It creates this kind of debris in there, as well as these wrinkles. And again, this is the settings. And finally, this effect here, which is actually an inverted erosion, which actually increases the volume of the dune. And that was like for the large scale dune, and I also have an example how it looks on smaller dunes. So this is again the first one. The only difference between these two is that I've just dropped the deposition rate here, because then it creates this kind of weird things there. Then here is the second one, pretty similar. Again, I've decreased the deposition rate as well as sediment capacity. And finally, this is the inverted, which kind of creates completely different look. And the idea behind this is just not to use a single erosion on the entire landscape. The key is to mask out certain areas and use many of these erosions at different places so that it kind of creates various details all around. And here, for example, I just quickly masked out by direction and just combined two of these erosions so that I can kind of get this more interesting effect here. All right, and after that, I split the height field into smaller, more manageable chunks and imported them directly into Unreal Engine along with some extracted maps from the height field. Now, you may be wondering why I polyreduce the mesh when I'm using UE5, which has nanite. The reason is that I used ray traced shadows, which in my experience look better than lumen shadows. However, they don't work very well with nanite meshes. So in order to use ray traced shadows, I had to decimate the mesh a bit to maintain a reasonable frame rate. Then I created various sand ripple materials in Substance Designer, and in Unreal Engine I created a landscape material where I mapped these textures based on the masks from Houdini. Okay, and that wraps up the dunes, and now we can move to the city. So here are the main points I had in mind when creating the city, which is by far the most complex and detailed environment in the film. Because it's surrounded by barren desert, I wanted to make it to stand out, so I tried to make the city feel alive and bustling. To emphasize its industrial focus, I chose a simple design combined with dirty textures and the ever-present smoke. This film was my first sci-fi project, so I had to gather a lot of references that I relied heavily on during the production. On the left, you can see some samples from the mood board, and on the right, you can see my attempt at the city. Okay, and now we come to the individual building blocks of the city. But before we get started, I need to give credit where credit is due, and I have to thank Simon Frustrate for his amazing sci-fi building tutorial that my generator is heavily inspired by. So I think it's not necessary to cover my breakdown here, and instead I would like to point you to his tutorial that you can find both on the SideFX website and on Simon's YouTube channel. Okay, and here you can see just some more examples of buildings I created for the city. And now we get to the texturing. So the texturing process was pretty straightforward. I created several procedural materials and applied them to different parts of the building. However, in some shots, there was a noticeable texture repetition on the buildings. So I ended up replacing the material on some buildings with a triplanar material that I created in the shader. Now with the layout, I wanted to emphasize its sci-fi look, so I came up with the idea that the infrastructure could have a circuit board pattern. Again, there are already some great tutorials for that online, so I don't think I need to go into that here, but instead I'll show you how I placed the buildings into this layout. So here on the left, you can see that if we randomly select a building and place it on the plan, the result is not very believable. Whereas on the right, we have something that already looks more like a city with smaller local centers and just generally more natural density of tall buildings. And here is a little peek into how this works. So basically we generate a noise texture, and based on the grayscale value, we determine the height of the buildings. But there's more we can do to make it look even better. So let's jump into Houdini and let's have a look. Alright, so I've prepared this example. So here we start with the layout. Then we add facet to remove inline points, and then polyframe to calculate point normals, so that later when we add buildings, they have the correct orientation. Speaking of which, here are 9 buildings, or actually just placeholders to keep it simple. And they are sorted from the smallest to the tallest. Then we plug them here inside this switch, and they are picked based on this point attribute building type that we calculate here inside this point wrangle. And then we have this attribute VOP, where we create our noise. So here is AA noise and a couple of controls so that we can shape the look of the noise texture. So actually, if I have a preview here, so basically as we change the parameters, we can tweak the noise with these controls here. Okay, and now let's take a look what it does. So by increasing this VOP noise intensity, we increase the influence of the VOP noise that defines which buildings are picked based on the grayscale value of the noise. And we can actually see this better if I disable this node. So now you can see that only the white areas have these tall buildings in there, which already looks quite good that we have these local centers with tall buildings. However, what we can also do is use this ramp, and if I just lower the value here, we can simulate the effect that like the tall buildings are only in the center of the city. Which is probably more realistic. However, now we don't have any taller buildings here. So what we can do is to introduce some randomness to this. So we can maybe create something like this. And of course, we can also change the look of the city by changing these parameters here right inside the VOP here. Alright, and now let's quickly go over how it works. So here we just get information like the current number of iteration, how many points do we have, how many building types, radius of the city, as well as the noise value from the VOP for the current point. And here we do our calculations. So first we get the distance of the current point to the center of the city, which is at 0, 0. And then we divide that distance by the city radius. So what that basically means is that if the point is away from the city center, close to the edge of the city, we get a value close to 1. And on the other hand, if the point is more to the center, we get a value closer to 0. And finally, here we select what building we want. So here we interpolate between 0 and the total number of buildings we have, which is 9. However, we count from 0, so we have to subtract 1 from this. So we actually interpolate between numbers 0 and 8 by the VOP noise value multiplied by the distance profile to control the height of the buildings with respect to their distance from the center. And here is the randomization. So if the current iteration is smaller than a specified value, we generate a random point between 0 and 1 and multiply that by the building number. So basically we pick a random building. Okay, and now let's take a quick look at the internal division. So here I started with a basic shape, and essentially by using poly extrude and groups, I was able to create these individual parts. In the end, I also used lot subdivision from SideFX Labs to create panels on the walls to kind of break them up and add some detail. Okay, and then I added a wall around the city to protect it from the elements. So here the base shape is basically a convex hull of the previous base shape. And then again, it's mostly about extruding and blasting polygons. In the end, I once again used lot subdivision to create the paneling effect. This slide then shows the process of creating the port building, which serves as the landing area and is the center of the whole city. Again, I tried to quickly come up with some interesting look by extruding different polygons and finally adding panel details to maintain the same visual style. Then here are just some more examples of different random seeds in the generator. And here you can see the individual parts and on the right the final result. And that's pretty much it from the city, and now let's quickly move on to the last part, which is about spaceships. So I needed a generator that would allow me to generate different types of ships, from military to cargo, while still having the same visual style that would match the rest of the movie. I also wanted them to look believable, and by that I mean that I wanted these machines to look like they could exist in the real world, so some of the features were also inspired by real aircraft. As you can see in the reference and on the final model on the right, I went for that faceted look that we can see on some stealth aircraft, such as the F-117 Nighthawk, for example. And then of course I borrowed some features from various ships from both games and movies. Here you can see the basic breakdown of the ship design, starting with randomly generated shapes and progressing to the final form. We still have a few minutes, so let's quickly jump into Houdini and take a closer look. Okay, so back in Houdini, here we start with this simple shape that we feed into this feedback loop, where we scatter just a bunch of these simple objects on top of each other. Then we use symmetry to make it symmetrical. We delete small pieces and voxelize, so now it's one connected piece. And then we run a couple of poly-reduce nodes so that we kind of get this faceted look. Then we use symmetry again to make it symmetrical. And now we want to make more space for the engine here. So what we can do is to generate this polygon here at the bottom of the ship. And then we use ray to calculate the distance between this polygon and the points on the bottom of the ship. And then we just push these points down, creating more space for the engine. Now we want to add more details to the surface. So here I have this paneling effect, which is based on this lot subdivision from SideFX Labs. And then I just poly extrude a couple of the faces there. Now let's take a look at the canopy. So we start with this grid. Then we project this to the surface of the ship. And then using lattice, we kind of push this sphere here on this position there. And of course, the reason why we do it this way is that every ship has a different height. And with this approach, the sphere always snaps to the correct position at the top of the ship. And then we just transform it to give it this more canopy look and do a couple of poly bevels, and that's pretty much it. And now let's take a look at guns here. First, we select just the front-facing polygons. Then we also delete polygons from the engine area, and also these small tiny polygons. And then we just scatter a bunch of points on them. And then on these points, we later copy just a couple of these gun meshes and get this result here. And finally, we add a couple of these details on the surface of the ship, like these probes, for example, to make the ship look a bit more interesting. And finally, we also add the engine. And this is pretty much the finished model here. Alright, and here are some more examples of ships generated by the generator. And now finally to the texturing process. So the ships were textured using various procedurally generated Sci-Fi panel materials. And later in Unreal Engine, I also mapped decals on the ships to make them look more interesting. And that's it. So I hope you found this presentation interesting and maybe took away some ideas for your projects. Sorry about the rush at the end. So if you have any questions, feel free to contact me. And thank you very much for watching and take care.